Yes, yes, we can take a short break now. So we resume in
5 minutes time.
5 minutes from now.
So I offer you the tea,
We
all of you.
we can have a coffee now.
I already started.
I see you're having a tea. So okay, I'm going to stop now. The room is open for anyone who can join us, and see you in 5 minutes. Okay, it's 11:30, and we can resume with the next presentation, which should be, let me check, combining SysML with Petri nets for the design of an urban traffic signal control. And I see the presenter is in the room.
Yes, I'm here.
Okay, so just a few seconds, or I guess 1 minute, so Professor Misra can join us again, because I don't see him.
Okay.
Okay, he is here. So, sir, we can resume with the presentations.
Hello. Moderator, can you hear me?
Yes, yes, I can. Can you hear me?
Live streaming is on.
Okay, Professor Misra, are you still with us?
Sorry, it was muted. Hello.
Okay.
Yeah, it was muted. Yes,
Yes,
I'm with you.
I can hear now. So we can resume with the presentations.
Yes, yes, yes. And now we have somebody is claiming that he is say part two. Yakub, are you there? Yakub, Shahid, Kazim, Glova, Michael Aravolo. Nobody is there. And this guy is saying he is there. I don't know.
I can see Lazy Souza.
Yeah,
He
Le
can
Sujeta is there.
for the next presentation. So if she can share the screen and the slide.
Hello, good morning.
Good morning.
Who is there?
Yeah, I'm the one. I've been here for a while, and it seems like no
Who?
one is happy.
Who?
Umar Ibrahim.
Umar, which paper?
No, I am supposed to present by 6 o'clock. I'm just attending the conference.
Okay.
No, which
My
office?
presentation.
Yeah,
No. My presentation is 6 p.m.
6 p.m. Okay, not
Yes,
now. Okay, not
not
now.
now. Yeah.
No, so you don't need it. No, I was calling
Yes.
presenter from the last session. He was claiming in my email, he is chatting that I am there. So let's go. Lise is going to present now.
Okay.
See, you can start.
Good morning. My name is Laís. My affiliation is the Federal University of Sergipe Praise. Today, I will present the article Combine SysML with Petrinet for the design of an urban traffic signal control. Modern cities are highly dependent on the crucial infrastructures required by cities and organizations, for example, urban traffic. Urban traffic is considered a problem and a challenge for cities and organizations in a city that aim to monitor and improve quality of life. This article proposed to address the problem of the architectural design of an urban traffic signal control systems with the modeling of the architectural elements, sensor controller and actuator, using the SysML block definition diagram and the internal behavior of each of these elements as submodels of Petri nets and combine these submodels into a single model. XML block definition diagram includes the elements controller, sensor, and the actuator of the architecture of an urban traffic signal control. The sensor sends information about the state of traffic to the controller. The controller sends signals to the actuator, and the actuator regulates traffic. This actuator model consists of three phases: green, yellow, and red, together with the requests from the signal to the controller and the responses from the controller to the signal. The places red, green, green end, yellow, and yellow end represent the signal. The places green start, answer is green, yellow start, answer is yellow, and the red start represent the solicitations and responses between actuator and the controller. This controller model consists of places I, green go, yellow go, green start, answer is green, yellow start, answer is yellow, and the red start. And the transitions IGG, GGEG, and EGI. For example, the controller I sends the green signal command to green go actuator when the transition IGG is enabled and deposits a token in place green start. This sensor model consists of place detect vehicle and the answers detect vehicle. The place detect vehicle sends information to the controller warning that a vehicle has been detected, and the places answers detect vehicle send information from the controller to the sensor as a form of response. The region chosen to model the case study consists of 6 traffic signals, illustrated by black circles. 2 select intersection are controlled by traffic signals, limiting left turns on either road. The combination of CML block definition diagram for elements, actuator, controller, and sensor form a complete model of the urban traffic signal control systems for the region chosen this case study. At this intersection, Road A has priority over Road B. It is important to emphasize that this design can be used at other intersections in the region. The behavior of the XML block definition diagram of the controls for intersections I1 and the I2, the region chosen in the case study. When the controller for intersection I1 sends the green signals to intersection I1, the controller for intersection I1 also sends the green signal to the controller for intersection I2. A similar design is used for the other controllers for the other intersections of a region. This article proposed the modeling of architectural elements of an urban traffic control systems using the XML block definition diagram and Petri nets to model the behavior of these elements. Future work will focus on modeling and software simulation of other case studies related to a city infrastructures and evaluating the Petri net model developed for the case study by checking its performance and behavior properties to identify possible flaws and correct the functions. Thank you.
Thank you. Okay. So if there are any questions for this presentation. No one? Okay then. So, Professor Misra, can you hear me? Can you give me a feedback that you are hear me?
Yeah, you are audible.
Okay, thank you. Thank you. So if Professor Misra is not hearing us or is not here, should we go ahead and present the next paper? Should be a Bayesian network model for the prognosis of the novel coronavirus COVID-19. Is any one of the presenters in the room? I can see any of the names. Also, to the spectators or the presenters who are in the room, may I ask you to change your name here on the Jitsi room so that we can see who is actually present eventually. Thank you for the cooperation.
Hello.
Hello, Professor Misra.
Yes. Sorry, there is some communication gap. I think so. Link is broken, right?
Yep, I can hear you now, however.
Yeah. Yes. So,
So,
so our next presenter is Aminu Saliu Jakari Ibrahim Nasir Sani Ajoge is there present. Is a guy. Anybody present? So it is 11:45. I hope that this Peter girl is present, right?
Hi, I'm present, yes.
Mm-hmm. Anybody else who is present here for this session?
Okay. Let's say good afternoon because where I am is kind of late. It's in the evening. I'm Ablative and I'm also for this particular session. Though my paper should come up at the last part. That is by 12:15. That is CST time, 12:15. So I don't know if I can go ahead and make my own presentation.
No. Wait. Abdul Latif is there, right?
Yes, sir.
Abdul Latif in SEPA 3. SEPA 3. Okay. Okay. No Kohe. Okay. Abdul Latif. But I think you was also, you missed in the SEPA 2 as well.
No. I only have only one. Only this particular paper in this one.
Okay. So SEPA 3. Abdul Latif, yeah, because we have time, we can talk. Who paid for your conference? Who paid the registration?
I would say maybe we paid ourselves because we had an issue back then with some of our sponsors. So we just tried to pay up before the deadline. So we paid ourselves.
So how did you pay?
I'm currently in Malaysia, so I can pay with my card from here.
Okay, you use your card, right? Your card was working
Yes,
because there
yes,
was an issue in the card from here. Okay, you are in Malaysia.
yes, sir.
You already paid it. It's okay.
All right.
Have you submitted any paper to the ICIIA?
I could not meet up because I had some other deadlines. I'm very, very sorry for that. It was quite a painful one. I could not meet up with the submission.
So in ICIIA, right?
Yes, sir. I could not meet up with it.
But if you have any still good paper, you can submit it in 1-2 days.
Okay, I'll get back to you on that, sir.
But to do it fast by today or tomorrow, right? He started
All
the
right.
review process.
Okay, sir. Thanks for the privilege.
No, because some of the authors has complained that they are coming, joining to listen a particular paper at a particular time. So that's why we are not shifting the presentation up and down.
I do understand. I understand.
You understand? So that's why, even though the second, and it is again a Nigerian authors who are absent at this time. Most of them they are making me highly disappointed.
I'm also disappointed too because I believe them to be professional enough to join at least for the session. If not
Yes.
for any other, at least you learn something from the presentations.
No, one guy is saying I'm present and I'm calling his name. He is saying that it's okay, I'm there. Where are you? I don't know. And then he is saying that I saw it is 11 a.m. This means for east to him, I have to present in their home time. I don't know what they are in their thinking. In this conference is always happening for their own. This is a Central European time.
Definitely, they are supposed to just at least
No,
be
highly
prepared for it.
disappointed. All those presentations. Since morning, I am facing this one. There are two papers has gone, and
Hello, just to checking, can you hear me?
yes, yes,
Okay, thank
Andrea,
you. Thank you.
Andre, right?
No, I'm Peter Gal.
Okay, Peter Gal. Okay, the next presenter, right?
Yes, from 12 o'clock.
12 o'clock. So how is the? You are in the. I guess that from my group, from is this your first time or it is your second or third time? If I'm not wrong.
It's my first time.
Okay, but you are from the same group from Hungary, right?
Yes.
So in between, I can also I can share something that there is a next conference going on. This is ICCSA, whose deadline is passed. It is also Springer CCIS. If any one of you are interested, maybe you can submit your papers. Still, we can consider. Right? So maybe this announcement. And also we have for the, you know that why the presentation is important. All the authors are present here. So I wish to announce that there are some best paper awards and you couldn't recognize that anytime your paper, your work can click. And this award is not a normal one. We pay 500 euro to each paper and we have more than 10 awards or minimum 10 awards every year. So the chances are very high, and we pay to the authors directly in their account. There is nothing, we are paying a gift. I think very rare conferences in the world who are adopting this one. We have also a lot of special issues as well. So you will be invited if your paper is selected for this special issues. We already done a lot of papers from each sessions in the several special issues, and of course those special issues are in the Scopus Index Journal, and some of them with the SCI with the impact factor. So these are the things. But if you will be not present your paper here, we cannot assess or we will not consider for any of the things which we are talking about, right? So that's why the presentation is not mandatory, especially for the Springer authors, but it is highly recommended for you guys to present, right? And also consider the comments of the reviewers very seriously, because we always check when we are giving an award that in a revised version the authors has done all those corrections as per the reviewers comment. And I observed that several of the papers, they have not considered very seriously the comments of the reviewers. Well, it may be go to the conference, it may publish to the and I'm sure that all of you are aware that your papers are published. They are already online. So you may enjoy your paper, but I always encourage. And also for the IEEE authors, I don't know that if any one of you are present here. For the IEEE authors, it is mandatory to present. If you are not presenting, even though you registered, we cannot help you because IEEE ask for a mandatory presentation. Any questions you have, we can talk. We are in a meeting, so this is a formal meeting of all those authors. And I really appreciate all of you that you have shown your interest. You have also means your confidence submitting papers since a long time, and we are obliged for all those of your contributions. Any question, anything you have, you can ask, please. You can just unmute your mic and you can speak something because I can see there are several guys are there. Right?
Okay.
Yes.
Well, Prof, first of all, I would just like to appreciate the organizers of this conference. It's a wonderful platform. This is my second time because I presented also in the last edition,
ICCSA.
also so. From what I experienced last time, prompted me to make this submission for this particular edition again. So hopefully, I'm under the impression of submitting more because I also find out is a CORE based conference, which is highly regarded where I am right here. So it really added to my portfolio also, and the experience also has been wonderful. At least I have learned from some of the presentations, and some ideas are also coming up from what people have presented. So it's a very good one, at least in my own opinion. It's a very good one for me. And being a young researcher, listening to people from different domains with different ideas, with different ways of doing things, I've learned more than I can even say I've even paid for. It's a very good one, and I so much appreciate the organizers. And just to say kudos to you.
It's okay. So let's hope to attend physically next year. If you will be in Malaysia, maybe they can sponsor your trip, right?
We wanted to use the grants here to come over, but the pandemic also played a kind of dealt a blow.
Yes, yes.
Even at the moment right now where I am, we are kind of on a partial lockdown, so we can't move around that easily. So, well, hopefully by next year, if
Next
everything
year,
is
yes. Next year,
back
yes.
to the new normal, then we can talk about that.
Also, you have not been in Nigeria since how long?
For like 4 years now, I've been away. 4 years.
So you have not returned back since 4 years.
Yes, sir.
So are you sponsored by any of the university?
No.
So are you
I'm working with a particular research unit here. So
project?
they have so we are working on it together.
Okay, so you are under project, right?
Yes, sir.
So when are you submitting your thesis?
Well, it is due for December, so I already put it in. So we are just waiting for the evaluators and have the final presentation.
Okay,
So everything should be ready.
it's okay. Thank you so much. Any other questions? Otherwise, let us allow to the next presenter. Peter can present it because it is only 5 past, so he can move up to the 12:15. Any other question from anybody? Okay, Peter, go ahead.
Okay, thank you. Just a second. I try to share my slides.
Are you also from Hungary, right?
Yes. I hope you
You're Hungarian
can see.
because the previous experience, your English is good.
Thank you. Okay, hopefully everyone can see the slides now.
Yes. Go ahead.
Just a second. Just muted some chats. Okay, so thank you. And I would like to present extending A+ with object-oriented elements. Concretely, a case study for A+.NET. And I'm Peter Gál from the Department of Software Engineering from University of Szeged, Hungary. Before we begin, I think we should talk about what is A+. Because most of us, I think, are not so familiar with this language. This is a derivation of an APL language. APL stands for a programming language from the 60s, which at the time required special font by default and a special keyboard. Mainly, it's an interpreted, array-based, imperative, dynamically typed language in the 60s, so it's still great. And A+ is a derivation of this whole language, adding extra financial, mathematical operations, and there are lots of built-in so-called operators, which are in different languages, should be functions, like matrix inverse, linear equation solver. These are all a single symbol in the language, both in APL and both in A+. I've brought an example for you, an A+ example. This small code looks very intimidating at first, because there are not so convenient symbols here and there. Basically, all of these symbols are strange for a modern C, C++, or Java programmer. But this program basically takes a set of file names and calculates the unique lines in these files. As you can see, weird symbols here and there. Hopefully it is, yeah, visible, sorry. One important aspect is, aside from this strange font in A+, is the precedence and the evaluation order of various operators. There is no precedence in between operators. For example, a plus operation and a multiplication operation have the same precedence in all cases. If you want to, well, make sure that the multiplication happens before the addition, then you need to use parentheses. And that's by design. It's also a relic from the APL era. For this weird font, there exists an A+ keyboard. The blue characters are the standard keyboard characters, and the red ones are the symbols used by A+. As you can see, it's not a typical QWERTY or QWERTZ keyboard. And this language is used today also, so there are developers using special fonts and keyboard layouts in their development environments, Emacs or Relay, something like that. In addition, the other part we need to consider is A+.NET, which we built on top of, which is a clear room implementation of the A+ language based on .NET, specifically C#. And we used dynamic language runtime to have some dynamicness in the language. This is also an interpreter-based implementation. This A+.NET allows two important things for us. Allows .NET functions to be used in A+ scripts, and vice versa, A+ functions in .NET language, basically, or C# languages, which is one of our previous work, but we went further with this object-oriented extension to add new symbols, new functionalities for the A+ language, because there are various libraries, algorithms, and code snippets for .NET C#, which would be ideal for mathematical or financial computations. And it would be really great if these functions, classes, could be used in A+ scripts also for A+ developers. But to access such classes, functions, usually a manual wrapper method is required. So you need to write manually each wrapper methods for different classes, different class methods, and so on, which is very time consuming. And usually they are just simple function calls inside them, so the same logic is used almost in every case. Thus, we evaluated a set of features which is required for a language to have object-oriented extensions. Especially in A+.NET, we would need to add a new type, basically a type which wraps .NET objects in itself, so we can do operations on them. For example, these new operations are accessing members, or modifying variables and properties, indexing these results provided by member access or something like that. And also, one important aspect is to do typecasting to resolve type or method ambiguities. And with these new elements and the implementation in A+.NET, the A+ developer does not need to write wrapper methods. They can just simply use these new operator symbols and mechanism to have the wrapper methods dynamically created for them in runtime. The first new symbol which we introduced for A+.NET is the small theta symbol, which serves two purposes. One is to access a class or instance member, which has this weird format that is you need to read it from right to left. So I want to access the instances member, basically. Or if we want to access the class constructor, we just have to use this theta symbol and the class name, which we can then access. This same symbol is used to do modifications for properties or variables in an instance or class. For example, this syntax, it's important to know this left arrow. This means we are assigning a value to this instances member. A short example for this is that we want to construct a datetime object from the C#.NET world. We use the data symbol to access the datetime class, and then we can call the constructor with these curly brackets, which will result in an object stored in a DT variable. Then we can access the property or modify the day property of this datetime by selecting the DT's day property with the same operator, theta operator, basically, select member operator. And the 15 value will be assigned to this property in this instance. The other new operation which we introduced mostly for .NET objects is the indexing operation which required. For this, no new symbol was required in this language because A+ already supports the same indexing as almost any other language. Interestingly, you can have multiple columns in the indexing, so you can select multiple dimensions in itself. For example, 9D matrices can be easily indexed this way. So basically, in our case, for our new A+.NET type, we just had to extend the functionality of the indexing operator in the A+ language to accommodate the new A+ type. Also, an example can be seen here down, where we create a sorted list with the same get member or get class syntax, which is then created. A new instance is created in the off variable. We store one of the proper members or indexed value is overwritten by 42, and then we can access this member in the same indexing operator. One of the last important operation is typecasting, especially explicit typecasting for .NET types. For this, we introduced the diamond symbol, which is previously not used in the A+ keyboard, A+ font, but it's there, so it can be used. And this format has almost the same logic as the get operator. That is, on the right-hand side, we have the instance or the class, which we want to typecast to the new type. One important question is, why do we need this cast operation in A+? As I mentioned, it's a dynamic language. Why doesn't it try or figure it out itself? The main reason for this is resolving type ambiguities in the C#.NET world. That is, in case of method resolution, for example, if we've got a class with a method, we want to select this method, and we want to call this method. This is an A+.NET example. Then with the typecasting, we can specify which method we want to select from these 3 methods, which is provided by one of the developers, for example. Because if we don't specify any typecasting, then the method resolution will perform using a number of arguments and the type distance calculation. In this example, as there's only one parameter for this method, the C# method int a1 and int a2, which has 2 parameters, is already out. The engine will not consider it because it has 2 parameters. We should not call that. But the other 2 cases where the argument is a double or integer should be considered. That's where the type distance calculation will come in, as the 1 is not a double value, but an integer value in an imaginary type, chain. The integer is before the double. So if I'm searching for an integer value, an integer parameter is found, then we can use this. However, if I want to use the other method, the double arg1 provided by the C# implementation, then we would need to explicitly cast this one integer value to double. So we can use that method. This is why the explicit typecasting for .NET is required. In summary, for A+, and broadly speaking for other dynamic languages, we introduced a set of operations and their internals, how should they work, to access, modify properties or variables, how can classes, instances be indexed, and an explicit typecasting operation. It is important to note that from these new operations provided in the language or added to the language is still not object-oriented, as we missing class semantics and other, for example, generics if we are talking about .NET. This is also our future work to add generic support, C# reference and output parameter support, full class semantics, so we should be able to create new classes in A+.NET to bring the language into the modern era with object-oriented programming scene. And also we'd like to provide more comparison with other languages, other dynamically typed languages, JavaScript maybe or TypeScript, to see how these operations hold on. And I think that's all from me. Thank you for hearing me.
Yes, nice presentation, Peter. It is.
Thank you.
I really like because it is core software engineering, right?
Yeah.
So it is an object oriented. So what is your major contribution? Sorry, if from the audience, if you have any questions, after then I will ask. Audience, please. This is a very good presentation. Please ask the questions. Yes, Peter, go ahead. What is the major contribution, and what do you think that how you can uh, means discriminate your work with the previous ones, and what is the major things you achieved it?
Here, I think the major points of the paper is that we identified a set of operations for not just a specific language, but for multiple languages which can be used to move a language towards object-oriented programming. And their basic internal functionality, how should they work, what should they do. And also this moves concretely A+ language closer to other object-oriented languages with these new semantics. On top, we can build other class semantics or other new things. That's my.
Can you make it more clear about the to the audience that what is the A plus? Because most of them they may not be familiar with the A plus.
Okay, just roll back to the example. So A+ is specially used language for mathematical and financial computations, used by example Morgan Stanley extensively. And the main important factor of A+ is that it has lots of built-in operations. As you can see from these symbols, the comma symbol is a concatenation, so joining vectors or matrices together. The up-down are take the first element or drop the first element. Sorting is a single character in the whole language. So if one can understand these symbols, they can easily and quickly write mathematical equations into A+ and execute it quickly. I hope this answers.
Yes. Yeah, it's okay. Any other questions from the audience, please? So, what is your future program?
Future is to add the future is to add full class semantics. That is, you should be able to write classes in A+ and not just use external classes from .NET.
Is it very close to the some formal languages?
No, not
Not
really.
really. Not really.
It's
Right?
closer to MATLAB or Maple
Okay, it is
in
closer.
their logic.
So you are a PhD, or you are already a faculty there?
I'm well working on submitting my PhD.
Okay, you are submitting your PhD. So how many years you are working?
4.
Oh, so this is your last year, but surprisingly,
Yes.
it is the first time in ICCSA, right?
Yes.
Why? We have not heard about this conference.
No, I heard, but I don't know why I didn't send previously.
Okay, no problem. So I'm expecting that next year also you are coming, right?
Hopefully.
And also, if you have any paper, you can submit to the ICCSA. Have you gotten any call for paper for ICCSA?
Yes, thank you.
So have you submitted anything?
No, unfortunately, I was unable to do.
Okay, it's okay. It's okay. I hope that everybody has enjoyed the lecture. In fact, I was just filling the gap of the time, and I'm expecting to the next presenter. This is again from Noho and Abdul Latif. Abdul Latif is there, right?
Yes, I'm here. I'm right here.
So, okay, you are working with Noho, right? From the Landmark University.
Yes, sir. Yes, sir.
Okay. So it's okay. Go ahead.
All right. I'll share my screen now.
This is the last presentation of this session.
Just a moment, please. This one. No, 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 no. All right, can you see my screen, please?
Yes, may let me. Yes, yes.
All right. I would like to welcome you all, and my name is Abdul Latif, like I said earlier. So I don't know the time wherever we all are, but I would like to say maybe good day, good afternoon, and good evening to you all. So I'm here to present this paper titled "Rotation Forest-Based Logistic Model Tree for Website Phishing Detection," and the kind of collaborative work with some of my colleagues, as you can see their name here. So for the presentation, I have this particular outline, the background, the aim itself, then the methodology used in the particular study, the results we're able to get, and some analysis we made from the results, then the conclusions. Um, but before we go into the main one, that website phishing detection, we all know that the web itself and internet technology is quite advancing. And even with the pandemic, we can see the usefulness because everything tends to move towards the web, or let's say towards the cyberspace, from education to finance to quite a number of things moving on to the web. So, but we know there's no kind of a generic rule for who and what can be on the web or what can be placed on the web, so to say. So this is a kind of a loophole for some cyber criminals to cause havoc. In a nutshell, this normally leads to a spike in the number of cybersecurity problems that we have over the years. And quite notably, this website phishing attack has been one of them. And from studies or from statistics and reports, we've seen that it has been rampaging quite from the years. In 2018, the APWG gave an estimated of over 51,000 phishing websites and also proof points to Verizon. And also Google itself also attested to this particular problem being a menace in the cyberspace. Uh, and the major reason why what we can put together for this is maybe for financial gain from the cyber attackers or from the cyber criminals, or maybe identity theft and hiding, such that a particular cyber criminal can steal another person's identity, commit nefarious crimes, then kind of a runaway. In that way, nobody will know who committed the actual crime. And it could be for fame and notoriety. These have been seen amongst young young hackers, or let's say the black hackers, where they do things just for fame or notoriety. So figure one just shows how they tends to camouflage a particular website and try to get data from unsuspecting user, whereby the user wouldn't know which is the legitimate site or not, because most of the time users are always in frenzy trying to hop on the web, maybe do fast shopping, do fast transaction without actually looking at some details to verify if the particular website they are on is legitimate or not. So there are some solutions over the years that have been used. First is the blacklisting, whereby a number of URLs have been aggregated on a particular or phishing website. But the problem with this is that working on the accumulated URLs is not sufficient. There's no room for new attacks. There's no room to for the method to capture new attacks effectively. So then we have the phishing awareness training, because people believe that, or experts believe that once you train people or trying to orientate people more on the problems of these cyber attacks, they will tend to be very careful. But this also, these cyber criminals have a way around it. They're now using kind of a complex method, or let's say dynamic method, just to circumvent all these kind of solutions being put in place to block all these phishing websites. The machine learning method is not, well, I wouldn't say it is new, but it's kind of a growing, and whereby you use specifically machine learning methods to detect like phishing URLs. And we can see this one is dependent on the performance of the adopted ML technique, which is one of the major things. And also, there may be data quality issues with the harvested URLs in the end of the day, maybe from class imbalance or to high dimensionality. But we can say from studies that ML techniques are fast growing and they are gaining ground. So the dynamism of phishing websites demand kind of sophisticated methods or sophisticated ML methods in order to detect these phishing websites with high detection accuracy and low false positive rate. So in this particular study, we are proposing this rotation forest based logistic model tree for website phishing detection. And for the methodology, For the LMT itself, is just the hybridization of decision tree and a linear logistic regression. In particular, we incorporated. This is not our own model itself. It has been created by Snevenel, one of the authors that created it. So they incorporated logistic model with the decision tree, whereby they place the logistic model at the leaf node of the decision tree in such a way that it will be able to uh, predict better or detect do the classification better, and it uses information gain in the form of an entropy for its own decision splitting when it comes to the nodes. And figure 2 here shows the pseudocode for the LMT as we have it here. So the parameters as used for developing this LMT is based on what you have in table 1. We follow this parameter, the splitting on residual, the use of AIC, and the batch number, first regression tree, the number of booting iterations, set to -1. That means it can go over and over and over again. So we now try to incorporate this rotation forest, which is a meta-learner approach, with LMT in a way to amplify the performance of LMT. So we propose this RFLMT, which stands for rotation forest-based logistic model tree, which is basically a meta-learner and produces a classifier model which also incorporates what we call the feature extraction, particularly a PCA. So the RFLMT kind of amplify the performance of the base learner, in this case LMT, by splitting the feature into n set and using the PCA on each of the generated subsets. And at the end is going to generate a more refined data set, which will be used to train the model. So the essence of the rotation is just to allow concurrent independence, accuracy, and diversity within the ensemble. And diversity is attained via the feature extraction, that is the PCA for each base learner, which will be the LMT in this case. So this is the algorithm that we coined for the RFLMT. It just we integrated the LMT in together with the rotation forest to generate this particular algorithm. So we kind of created an experimental procedure to test the performance of LMT and also RFLMT in this particular study. And from figure 4, we can see the experimental framework where we kind of had fishing data set, which we already called online, which are already existing fishing website data set from the from the UCL repository. And we use some base learners on them, the MLP, the instance-based learner, that is KNS neighbor decision tree and Bayesian network. All these ones that have different computational complexity. MLP is from function, KNN from instance-based learner. Decision tree is from the tree-based classifiers, while Bayesian network is from the bias-based classifier. So we kind of check the performance alongside normal MLT. So to see the performance of MLT itself against these baseline classifier. Then we also compare the performance of LMT with the enhanced MLT in form of the RFLMT to see if at all the rotation forest is able to amplify the performance of the LMT in terms of detecting a phishing website. And all the models were based on crossword validation, where our k is equals to 10, and we evaluated the model based on some particular assessment characteristics like the detection accuracy, the false positive rate, the F measure value, the area under curve value, even the multi correlation value also to see, to measure the performance of all these models accordingly. So table 2 here shows the data set that we used. All of the data set are pre-existing and they are called from the UCL repository, and we gather some of them also from existing studies. Then we use the performance measures, performance evaluation metrics to measure the performance of all the ensued models from the experimentation. So for the result, table 3, table 4, and table 5 here shows us the performance of LMT with the selected base class learner that I said earlier on the set A, B, and C. So quite from table 3, we can see LMT has kind of a better accuracy value, but we did not even stop on that only. We look at the AUC value and the MCC, but they show better comparison. Apart from the accuracy, accuracy could be maybe the model is overfitting. That's why we don't want to base on accuracy only. But looking at the MCC value, that is the multi correlation value, and the AUC value, it's quite apparent that this particular method is kind of superior to the baseline classifier. The one that moves very close to it is the KNN. But the problem with KNN is the hyperparameterization, which is very hard to deduce. It has so many parameters, and it may cause problem in trying to pick the best parameter whenever you want to use it. And also we can see on the set B also, the LMT kind of has superior performance, and also on the set C also, the LMT has superior performance. So we can infer, based on this particular experimentation, that LMT is kind of comparable. It kind of have a comparable effect over the existing or the baseline classifiers that have been used in this case. So we move further on to now compare the performance of LMT with the rotation ferret based LMT. Like we said earlier, quite knowing fully well that the rotation ferret based LMT is just using a meta learner with the LMT tried to amplify the performance of LMT. So from table 6, you can see the result based on data set A. From table 7, the result based on data set B. And from table 8, the result based on data set C. So we can see clearly that the performance of the RFLMT is kind of superior to LMT itself on the set A, B, and C accordingly. So we also compare the results of these proposed random forest LMT with existing studies. So we try to call the other existing studies to see how we can compare. So comparing it with under set A, these are the number of studies that have already implemented the set A, and based on different times. So we kind of compare the performance based on accuracy. We can see the accuracy of the proposed method is kind of superior. And not all of the studies use matrix correlation, but in our case, we used it. And we compare based on the available metrics as we've found in existing studies. Same thing we applied to the data B also. We compare the proposed study, as you can see here in table 10. It also supersedes the existing method, and also the data set C, as you can also see here. So this kind of shows a particular way that this RFLMT can be good or kind of perform quite well for detecting a phishing website. Though we cannot generalize, you can say for sure that it's the best method, but it kind of shows us that it can also act comparable to any of the existing methods that we have at hand for this time. And one of the best thing about this RFLMT is the explainability that is able to deduce from the decision tree. From the LMT itself, we're going to construct the decision tree at the end of the day, which kind of help us to understand how this detection actually takes place. And that is one of the advantages of this RFLMT. So if we are to conclude, we can say adjectively that the LMT supersedes or kind of act superior to the baseline classifiers. And when we integrated it with the rotation forest, it also shows very good performance over the LMT. And we can see that the proposed RFLMT also has comparable performance or kind of superior performance to some existing ML-based website phishing models, as we've seen in previous slides. So we can now recommend that RFLMT should be used for website phishing detection. So to move on with this particular study, we are trying to incorporate this RFLMT for the explainability part. We are using some of the rules that's going to generate on real life data sets, on real life scenario, in such a way it will help us to do the detection quite better than working in a black box. So since we know the rules will be generated from the trees, then we'll be able to incorporate them in the real life scenario. And we tend to further enhance the LMT itself, but this is just one of the scope of the study itself, using rotation forest. We want to extend the LMT itself to see how well we can even use it to increase its performance. Since we can incorporate a linear regression tree, a linear regression function at the nodes of the decision tree, why don't we also incorporate other form of maybe a multivariate regression on the tree itself to see how far it's going to go in detection itself, and maybe amplify the ensuing model at the end of the day. These are some of the future work that we propose to do at the end of this particular before we get to the end of this particular study. All right, and these are some of the references that we used in the key references we used in this particular study. All right, thank you very much.
It is a nice presentation, Abdul Latif. Yes, nice to hear you. Any questions from the authors?
What do you say, sir?
No, I'm announcing any questions or query from the audience, because I can see several of them. They are there. Please ask the questions. In absence of that one, Abdul Latif, can you tell me that why you means this particular algorithm is already a proved algorithm, right? that it is performing better in several instances. So, what's your new contribution?
Okay, sir. For the LMT, like I said earlier, we are not the I wouldn't say we are not the creator of that particular LMT, but
Yes.
the actual thing we are trying to enhance LMT itself. So for the first point, we try to see if we can use some of the existing meta learners. Of course, we can use maybe the boosting or the bagging. Those have been quite used well in existing studies. So we try to use rotation forest to see how the LMT would perform itself before we start doing our own enhancements. And like I said towards the end of my presentation, the LMT itself is using the linear regression on the leaf node. We are trying to propose using like a multivariate regression on the leaf node to see how it's going to scale up. And of course, the performance may be close to themselves, but we believe that will be a point in a particular direction because LMT itself hasn't been used in quite a number of studies. So we believe if we can dwell more into it, we'll be able to get something out of it. Then the explainability of the LMT itself is one of its advantages that it had over ordinary decision tree. Decision tree also is explainable, but it doesn't have anything to deal for. It doesn't have any certification at the leaf node for the evaluation at the leaf node. Why the LMT has a linear regression, which is the plus over normal decision tree. So we are trying to enhance kind of LMT to see how far we can go with it and try to deploy it in a real life scenario.
Okay, thank you so much. This means
very
we have hope that you can also improve the algorithm if you are finding some, you can do some adjustment, right?
Yes, sir,
Have
we
you
are working
published
on it.
any? Yes. Have you published any journal paper on this same?
We on phishing detection on website phishing detection itself, we publish quite a number. We for I have we have like a team. One of the lead team also himself is in Saudi Arabia, Mr. Yassan. So we published quite like 3 or 4 papers right now. But for the major one that we are proposing, we are kind of working on this closely. So and I may not be able to say more details because we are with under NDA with a particular organization here. So I will not be able to shed more light on it. But we are working on trying to push it to a real life scenario to see how far it's going to work before we move into the research-based part where we'll use the proposed method on existing data sets.
Okay.
Okay, sir.
So this means you are trying to extend this paper as well, right?
Yes, sir.
So, okay. So, what is next?
Okay. Oh,
I'm
well.
asking.
All right. Now we are still in the evaluation stage, so we only try to push this paper out at least to have like audience, to have like a presence in the research domain. That's why we have to push this particular paper out. And ICCSA is a very good platform for us to use. That's why we chose it, and we are kind of grateful for using it as a platform. So we try once we are done with it. Hopefully, I can speak with my team. We can come over to the next edition of ICCSA to showcase our the advancement that we've done on the proposed study.
No, before that one, ICIIA, if you have some good work, but a small work, you can submit it by today or tomorrow, right? Don't wait for the ICCSA. It's okay at the junctions. I again invite you to, I think all of the authors, you got the call for the ICIIA. It is still open, although I have distributed the papers for the review and we are running behind time. So, in absence of any other questions, I think the session is ending because in Italy it is already 12:35 and this is a lunch time. So, we are going to for a lunch at present, and we are
Yes.
going to meet in the next session at 4 p.m. Nigerian time 3, and you can calculate your own time because it is a Central European time. Andre,
Okay.
yes. Anything you want to say? Otherwise, we will close for approximately 3 hours. Right? 3 hours, 25 minutes.
Yeah, we have the lunch break now, and we will resume here at 4 p.m. Central Europe time.
Yes.
Before that, there is the keynote speaker having a lecture. So
Yes, please go to the ICCA schedule program. You can find everything there. So you can,
I can share it in the chat room if you want. Just a second.
yes, it is the program is here.
This is the program, as you can see. And
Yes,
I have to okay, I have to ask you to kindly leave the room as I have to close it soon for
yes,
the
okay. So have a nice lunch. Okay, goodbye. See you again at 4 p.m., right?
yes,
Bye-bye.
yes. See you later.
At 4 p.m. Bye-bye.
Goodbye. Oh.